आज की क्लास में हम लोग प्रैक्टिकल से रिलेटेड डिफरेंट पॉइंट्स स्टडी करेंगे. वी विल स्टडी द टेस्ट ऑफ गैस, its related observations. Similarly, in the subsequent topics, we will study the taste of anions, and the taste of cations has been given in our analytical chemistry topic. So, in practical, when you have to write some observation, you have to identify the gas produced. Sometimes, on the basis of the observation given, you have to identify the gas which is evolved, or you have to identify the anion or cation present in the given salt. Sometimes in the question, even in theoretical paper, it is given that identify the salt on the basis of given observation. At that time, you will be given two part of observation. The one observation based on practical will give you identification of the cation, and the other part will give you the identification of anion. Now, after identifying the cation and anion, you will find out the salt to be tested, salt to be studied. So, our today's topic is related to practical or related to observation. So, start with the practical and observations. It is important part because when in some questions, that is, suppose you have to derive observation, question is asked in ICSE, what do you observe when this is reacted with this? Then the observation is written on the basis of the products formed. It may be the evolution of gas, so you will write its observation, which type of gas is evolved, as well as on the basis of the different types of precipitate or the other points, you will identify the anion or cation and write its observation. So, in first part of it, I am going to start with the identification of gas. So, our first part is identification and observation of gas. Now we will study different types of gases along with some producing equations and observation that will give you idea of that particular gas. Like, suppose starting with hydrogen. How will the question be asked? Now suppose in the question it will be given that suppose granulated zinc is added to dilute sulfuric acid. So we see that when an acid, dilute acid, is added to active metals, when dilute acids, it may be HCl or H2SO4. Actually, nitric acid is not used here because nitric acid is a strong oxidizing agent. So, it oxidizes hydrogen produced to water. As a result, we will not get hydrogen in that case. So, in that case, when dilute acid is added to active metals, then H2 gas is evolved. Like you see, that is, suppose we take zinc, granulated zinc, we write here granulated zinc, or also write zinc granules. Suppose we take dilute HCl or dilute H2SO4, then the product will be ZnCl2 plus H2. Now, how will you identify it? What will be your observations? A colorless, odorless, neutral gas. Now you see, we use the term neutral gas. Neutral gas means it will have no effect on litmus paper or litmus solution. It means it is neutral in nature. Is evolved, which burns with pale blue flame and popping sound in air. So this is the observation related to hydrogen gas. Means, a student, you see that if the reaction is conducted and the gas is produced which gives this type of observation, it means that it is hydrogen gas. So you will be able to identify it easily. Again, remember, colorless, odorless, neutral gas is evolved which burns with pale blue flame and pop sound in air. If a glowing splinter or burning splinter is brought at the mouth of the gas jar, the gas will smoothly burn with blue flame. But when a jet of hydrogen is burnt in air, then it will burn with pale blue flame and pop sound. So this is the first gas studied by us, that is hydrogen. Students, on the similar basis, we will study the other gases that will help you in identifying the different gases. Like, they take another gas, oxygen, O2. Now we know that when an oxidizing agent is heated, then oxygen gas is evolved. Or suppose when potassium nitrate or sodium nitrate is heated, oxygen gas is evolved. So in that case, we will have to write its observation. Like suppose you see, that is for the oxygen gas, now you write potassium nitrate or sodium nitrate. When they are heated, they decompose partly. Giving their nitrite plus O2. Or suppose we write here Pb3O4, it is an oxidizing agent. If it is heated strongly, it gives us PbO plus O2. Now you can write here PbO 2, it is 6, and then O2. Now what is its observation? What is the nature of the gas? Now in general, just we are writing for oxygen, we are not writing all these things. We will later on study the proper observation. Now observation for the gas. A colorless, a colorless, odorless, neutral gas. Colorless, odorless, neutral gas is produced. We do not write here evolved, because evolution word will be used when the reaction will be taking place in solution state. Then the bubbles of the gas will rise. At that place we will use the term evolve. But here just we write produced. A colorless, odorless, neutral gas is produced, which now it has two tastes. One which rekindles, or sometimes we also write relights, glowing splinter, glowing splinter. Now oxygen gas is itself non-combustible, but it is supporter of combustion. So when a glowing splinter means the splinter, the very fine piece of wood which is glowing, means just it is reddish, burning with reddish end, but it is not burning with flame. That is called glowing splinter, or a smoldering incandescent stick, yani agarbatti. When it is placed in the gas jar of oxygen, then it will burst into flame. That is called rekindles or relight. Means that a smoldering incandescent stick or glowing splinter will start to burn automatically with flame. That is called rekindles. First, taste of oxygen. Second, it turns colorless alkaline pyrogallol, that is an organic compound mixture. Alkaline pyrogallol, we also use the word pyrogallic acid, to brown. This is the taste of oxygen. It is colorless, odorless, neutral gas which rekindles glowing splinter or relights glowing splinter. This is the oxygen. Or the colorless neutral gas which turns colorless alkaline pyrogallol to brown. So this is the taste for oxygen gas. Now students, we have studied two gases. Now come to the next part. The next gas is carbon dioxide. Carbon dioxide, CO2. Now, how is the carbon dioxide produced? When dilute acid is added to metal carbonate or bicarbonate, then CO2 gas is evolved. Or suppose when a metal carbonate is heated strongly, like calcium carbonate is heated strongly, then CO2 gas will be evolved. Now, what is the nature of this gas? It is colorless, odorless, neutral gas. And here you have to remember that it turns lime water milky or turbid due to the formation of calcium carbonate, which is a white compound and insoluble. As well as when excess of this gas is passed through that solution, then milkiness disappears. This is a test for CO2. But this test is also performed by sulfur dioxide. So we must use the another test to distinguish it from sulfur dioxide. As a result, we write here that the gas has no effect on acidified potassium dichromate solution or alkaline potassium permanganate solution, which will be changed by SO2 gas. So, like you see, suppose dilute acid is added to any carbonate, suppose Na2CO3 plus HCl, H2SO4 or any other acid like nitric acid and so on, HNO3. Now, in all these cases, what will be observed? It gives salt plus water and then the CO2 gas is evolved. Dilute acid, this is also the property of an acid. When dilute acid is added to metal carbonate or bicarbonate, then CO2 gas is evolved. Now what will you write in observation in this case? Observation. A colorless, odorless, acidic gas. Acidic gas. Now here it is colorless, odorless, acidic gas. Means it will affect, it will change blue litmus paper to red, moist blue litmus paper to red. This is the test for acidic gas. While using litmus paper, we must use the word moist because the gas will dissolve in water or in the presence of water will show its acidic property. So, acidic gas is evolved with effervescence. Effervescence. Effervescence means boiling or rapid bubbling. Effervescence, which turns lime water milky. Milky or turbid. This is the test for CO2. But as we have studied, as I have told you, that this test is also shared by sulfur dioxide. So we must write another part which will distinguish it from SO2. Although this word is capable of distinguishing from SO2 because SO2 will have some smell of burning sulfur. Now, but here you can write turns lime water milky, but has no effect on acidified K2Cr2O7 solution, potassium dichromate solution, which is orange in color. SO2 will turn it green, but here it has CO2 has no effect on acidified potassium dichromate solution or alkaline KMnO4 solution, which is pink otherwise. So now there are characteristics of CO2: colorless, odorless, acidic gas, which turns lime water milky but has no effect on acidified potassium dichromate or alkaline potassium permanganate. So this is the test for CO2 gas. Now here we have used the term has no effect, turns lime water milky. But now you see that when excess of CO2 is passed through lime water, then milkiness disappears. Now what is the reaction? Like you see, this is lime water. Actually, calcium hydroxide is used in three forms. Slaked lime, that is the solid calcium hydroxide. Milk of lime, suspension of calcium hydroxide in water. And lime water, that is when it is added to water, it dissolves partly and the excess of it gets sedimented. The upper clear solution is called lime water. So lime water, when CO2 is passed, it forms calcium carbonate plus H2O. Now it adds, this is white, so it turns lime water milky. But when excess of CO2 is passed, like suppose in the mixture we have this part, more CO2, that is excess, is added to it, then it forms calcium bicarbonate and it becomes colorless solution, hence the milkiness disappears. So students, this was about carbon dioxide in any reaction, in any practical, in any observation. Wherever CO2 is produced, you will write this type of observation, or on the basis of this type of observation you will write the gas evolved is carbon dioxide. So now the next gas. Next gas is sulfur dioxide. Sulfur dioxide, that is SO2. Now students, sulfur dioxide is obtained, like suppose when metal sulfide is roasted, means metal sulfide is heated in air or burnt in air, or when dilute acid is added to metal sulfite or bisulfite, then SO2 gas is evolved. So you see here, that is suppose we write here Na2SO3 plus dilute H2SO4 or dilute H2HCl or dilute HNO3, means we can see here, that is we are using dilute acids. That is when dilute acid is added to metal sulfite or bisulfite. Bisulfite means, suppose we take like this, metal bisulfite, then what will be the product? The salt of the metal. In this case there will be chloride, in this case sulfate, here nitrate, plus H2O plus SO2 gas. Now students, you see that the chemical reaction or equation of sulfite with acid is similar to that of carbonate. Just in place of C, here S means sulfur is used. Now how will you write here? You will see here, that is observation, like you see, a colorless acidic gas. Now you can see here there is no odorless, but we write here acidic, that is colorless acidic gas having a smell of burning sulfur. A smell of burning sulfur. Now, colorless acidic gas having a smell of burning sulfur is evolved, which turns acidified K2Cr2O7 from orange to green. This is the first observation. Turns acidified potassium dichromate, we write here point 1, turns acidified potassium dichromate from orange to green, or alkaline potassium permanganate from pink to colorless. Pink to colorless. Now, both these tests are for its reducing agent. SO2 is a reducing agent. So, if you have to write equation to show the reducing property of sulfur dioxide, then you can use the following reactions. Like for this one, K2Cr2O7, K2Cr2O7 acidified with sulfuric acid plus SO2. Now, by reduction, this one, here the oxygen part will be decomposed. Potassium will form its sulfate K2SO4 plus chromium will also form its sulfate and then H2O is formed. Now, actually this was orange in color and this is green in color. So the solution turns green. Now the equation is not balanced. Now it is balanced. So when SO2 gas is passed through acidified potassium dichromate solution, then it turns from orange to green. So this is the test for sulfur dioxide. You can take this one. When SO2 is passed through alkaline potassium permanganate solution, then this was pink in color. Now it will turn to colorless, giving K2SO4 plus MnSO4 plus H2SO4. Now it is balanced here. 2, 2, this is 5, 5. Now the equation here 2H2SO4, 2H2O. So it is the reaction. 2Mn, here you will write 2. Now the equation is balanced. So this time KMnO4 was pink in color and now this becomes colorless solution. So these two were the reactions or the tests for sulfur dioxide gas. Now students, we have studied 4 gases here. Now the next gas. The next gas is hydrogen sulfide. Hydrogen sulfide. That is, the 5th gas is hydrogen sulfide. Hydrogen sulfide, that is H2S. Now, how is the H2S produced? One hydrogen gas is passed through molten sulfur or we can react hydrogen directly with sulfur. It will be hydrogen sulfide gas. But in practicals, this is the not method to obtain it. In practicals, when dilute acid is added to the metal sulfide, then H2S gas is evolved. Means we write here dilute acid is added to metal sulfide. Here HNO3 is not used. Nitric acid is not used again due to its a strong oxidizing property or oxidizing nature. Now you see, like suppose we take ZNS plus dilute HCl. So students, you see that this type of reactions will also help us in studying the acid chapters or the different related chapters for production of respective gas or any other parts. Now, when dilute acid is added to metal sulfide, then we get here salt plus H2S gas. Salt plus H2S gas. Now, what will be your observation? Observations. A colorless, again colorless, acidic gas, colorless acidic gas having a smell of rotten egg. This is a characteristic test, sometimes also written as foul smell. So this is a smell of rotten egg, characteristic of hydrogen sulfide gas. And again here is the test which turns moist lead acetate paper black. Sometimes we also write silvery black or simply black. Or when it is passed through lead acetate solution, then black precipitate is formed. That is, when passed through lead acetate solution, black precipitate is formed. Black precipitate is formed. Now, what is the cause of formation of turning to black or formation of black precipitate? Now you see here, that is, in this case, actually the lead's double decomposition reaction takes place, and that is when H2S gas is passed through the solution or moist lead acetate paper is introduced in the gas jar, then double decomposition reaction takes place and metals lead sulfide is formed, which is black in color. So you write here, that is Pb CH3COO whole twice. This is the lead acetate plus H2S. Whether moist lead acetate paper is introduced in the gas jar or this is passed through the solution of this, then in this case you see you will get PbS. This is the black precipitate and hydrogen will be added to this part, giving you respective acid, that is acetic acid. This is the black color. So this is the test for hydrogen sulfide gas. Hydrogen sulfide gas has no effect on potassium permanganate solution. So we also use this test, but this was the secondary test. First test was sufficient to describe it.